Picture a world where towering monuments were built without cranes, where intricate devices operated with precision, long before the age of computers and engineers. This isn't science fiction. This is our own history, filled with ancient technologies so advanced, so baffling, that even today, with all our cutting-edge tools and knowledge, we still can't fully understand, let alone recreate them. How did civilizations thousands of years ago achieve what modern science struggles to explain? That's the mystery we're diving into today. From forgotten machinery to lost construction techniques, these aren't just relics of the past, they're puzzles that defy our assumptions about human ingenuity. Think about the last time you marveled at a skyscraper or the latest smartphone. Now imagine if, centuries from now, people looked back at our achievements and couldn't figure out how we pulled them off. That's exactly what's happening right now with the incredible inventions of ancient cultures. Some of these technologies were so ahead of their time, they seem almost otherworldly. And yet, they were real, built by hands just like ours, without blueprints or modern tools. What did they know that we've forgotten? How did they solve problems we still grapple with today? This video isn't just a list of curiosities, it's a journey into the mind-bending accomplishments of our ancestors. We'll explore 30 ancient technologies that leave scientists scratching their heads, from self-healing materials to energy systems we can't replicate. Each one is a testament to human creativity, a reminder that innovation isn't just about the tools you have, but the vision you bring to them. So if you're ready to uncover secrets that have endured for millennia, to see the past in a whole new light, then let's begin. The answers and the mysteries are waiting. Buried beneath the waves off the coast of a tiny Greek island for over 2,000 years, a lump of corroded bronze would rewrite history. When divers discovered the Antikythera Mechanism in a shipwreck in 1901, they had no idea they'd stumbled upon what experts now call the world's first analog computer. At first glance, it looked like nothing more than a damaged artifact, until researchers realized its intricate gears formed a sophisticated system designed to track the cosmos with staggering precision. This wasn't just a calendar or simple clock. The mechanism could predict solar eclipses years in advance, chart the positions of the 5 known planets, and even account for the irregular orbit of the Moon, all through a complex arrangement of over 30 interlocking bronze gears. Think of it as an ancient Greek smartphone for the stars, compacting celestial mechanics into a handheld device. What's truly baffling, nothing this advanced appears again in historical records for over 1,000 years. Modern engineers have tried recreating the Antikythera mechanism, using cutting-edge technology to reverse engineer its design. Yet even with X-rays and 3-dimensional modeling, some of its functions remain unexplained. The craftsmanship is so precise, so ahead of its time, that experts still debate how ancient artisans achieved such tolerances without modern tools. Who were these masterminds? Ancient texts mention legends like Archimedes or Posidonius, but the truth is, we may never know. The mechanism hints at a whole lineage of lost knowledge, a school of engineering and astronomy that vanished beneath the sands of time. Here's what haunts researchers most. If this was the one that survived, what other marvels were lost? The Antikythera mechanism wasn't just a fluke. It was proof that an entire world of ancient innovation lies buried, waiting to shatter our assumptions about the past. Every gear, every inscription whispers the same question: how much more did they know? The Roman Empire built structures meant to last not just decades but millennia. While modern concrete crumbles after 50 years under seawater, their harbors and piers still stand firm after 2000. The secret, a recipe so effective we still haven't fully cracked it. Roman concrete didn't just resist erosion, it grew stronger in water, defying logic and time. Modern engineers use Portland cement, a 19th century invention that relies on steel reinforcements to prevent cracks. But steel rusts, and when it does, the concrete splits apart. The Romans needed no such crutches. Their mixture, a blend of lime, volcanic ash, and seawater, triggered a chemical reaction that actually repaired cracks over time. Tiny mineral fibers would grow between fractures, knitting the material back together like living tissue. The Pantheon's dome, still the world's largest unreinforced concrete structure, is a testament to its endurance. Rain, earthquakes, even pollution have barely touched it. For years, scientists assumed the key was pozzolana, a volcanic ash from the Bay of Naples. But when they tried replicating the formula, something was missing. Recent studies found traces of rare minerals like aluminum tobamorite, which forms under extreme heat and pressure, conditions the Romans couldn't possibly have engineered. Unless they stumbled onto a geochemical fluke, we're overlooking a crucial step in their process. The mystery deepens underwater. Dive near an ancient Roman breakwater, and you'll find it coated with a rugged crust of minerals almost like armor. Modern concrete, by contrast, dissolves in salt water, requiring constant repairs. Researchers now suspect the Romans exploited a self-healing mechanism, seawater reacting with their mix to form new crystals that seal gaps. But every attempt to recreate this effect falls short. Perhaps the most humbling detail, the Romans didn't even consider this their finest work. Texts from the era casually mention the recipe as common knowledge, like a baker sharing a bread formula. What else did they know that we've forgotten? Their concrete whispers a truth that unsettles our modern arrogance. Some secrets of the past refuse to be rediscovered. The swords that gleamed in the hands of medieval warriors weren't just weapons, they were masterpieces of metallurgy that have never been equaled. Damascus steel blades, forged between the 3rd and 17th centuries, weren't merely strong. They could slice through lesser swords like paper, hold an edge sharper than a surgeon's scalpel, and flex like a willow branch without breaking. Crusaders returning from the Middle East told tales of these legendary blades cleaving rocks and even floating hairs that touched their edges. But what made them so extraordinary wasn't magic. It was a manufacturing secret so complex we still can't reproduce it today. At the heart of the mystery lies Wootz steel, a rare ingot imported from India and Sri Lanka. Blacksmiths would heat, fold, and hammer this steel hundreds of times, creating microscopic layers that formed its distinctive watery pattern, like ripples on a dark pond. But modern attempts using the same ingredients fail spectacularly. Scientists analyzing original blades found carbon nanotubes nested within the metal structure, something we only learned to create in labs in the 1990s. These microscopic reinforcements gave the steel both unbelievable flexibility and hardness, a combination modern metallurgists call the impossible balance. The lost technique goes beyond mere recipe. X-rays reveal that Damascus steel contains traces of rare elements like vanadium and tungsten, suggesting medieval smiths somehow harnessed impurities in the ore to enhance strength. Some theories suggest the metal was quenched in unusual mediums, perhaps pomegranate juice or animal urine, to achieve its unique crystalline structure. Others point to the slow cooling process in specific atmospheric conditions that allowed carbon to arrange itself in ways we still don't fully understand. Perhaps most frustrating is that we have written records from medieval Arab scholars detailing parts of the process, yet following these instructions never yields the same results. Like trying to bake a cake with half the recipe, we're missing some crucial step. Maybe the temperature of the forge, the rhythm of the hammer strikes, or even the composition of the air during smelting. The original Damascus steel remains a whisper from the past, taunting us with what we've lost. What's truly humbling, these blades weren't just functional, they were works of art. The swirling patterns weren't merely decorative, they revealed the steel's internal structure, each ripple marking where layers fused under the hammer. A master smith could read these patterns like a fingerprint, knowing exactly how the sword would perform in battle. Today's closest imitation, pattern-welded steel, creates similar visuals through artificial layering, but lacks the molecular harmony that made Damascus blades peerless. Stand in a museum before one of these surviving swords, and you'll notice something eerie after centuries. The metal shows almost no corrosion. Modern replicas rust within decades, but the originals gleam as if frozen in time. Whatever secret technique those ancient smiths guarded, it wasn't just about creating a superior weapon. It was about mastering metal itself in ways that still defy our understanding. Every failed modern attempt to recreate Damascus steel whispers the same unsettling truth: some knowledge, once lost, may never be found again. Imagine a weapon so terrifying, it could set entire fleets ablaze, flames leaping across the water's surface, defying every attempt to extinguish them. This wasn't some mythical dragon's breath. It was Greek fire, the Byzantine Empire's most closely guarded secret, a technological nightmare that kept enemies at bay for centuries. Unlike ordinary fire, this substance clung to ships, burned fiercely even in rain, and most chillingly ignited on contact with water. Some warriors claimed it could only be smothered with sand or vinegar, while others swore it pursued victims like a living thing. The Byzantines deployed Greek fire through bronze tubes mounted on their ships, spewing jets of liquid flame that could reach distances modern historians estimate at over 30 meters. Contemporary accounts describe the horror of sailors trapped in infernos that water-only fueled flames dancing atop waves, turning the sea itself into a death trap. The psychological impact was as devastating as the physical damage. Entire armies fled at rumors of its use, and the mere sight of the distinctive bronze siphons could break enemy morale. So what made this ancient napalm so unstoppable? The recipe was a state secret so valuable, emperors entrusted it only to their closest kin. Modern chemists have pieced together clues from fragmented texts and battlefield residues. The base likely included crude petroleum from surface deposits near the Black Sea, mixed with resins or quicklime to create a sticky, self-igniting gel. Some theories suggest additives like sulfur or saltpeter intensified the combustion, while others point to distilled pine tar as the key to its water-resistant properties. Yet every attempt to recreate Greek fire falls short. Laboratory versions either lack the legendary intensity or fail to replicate its most haunting trait, the ability to burn on water. Byzantine engineers may have exploited a chemical reaction we still don't fully grasp, perhaps using pressurized delivery systems to aerosolize the mixture mid-air. There's even speculation that the formula evolved over time, adapting to counter new enemy tactics. The greatest mystery isn't just the ingredients, it's how the Byzantines maintained absolute secrecy for nearly 500 years. Craftsmen working on the mixture reportedly labored in isolated workshops, forbidden from communicating with outsiders. Knowledge was compartmentalized. No single person knew the entire process. When the empire finally fell, the secret vanished so completely that not even a single intact recipe survives today. What lingers is the unsettling realization that a civilization 1,000 years behind modern science mastered combustion in ways we can't quite reverse engineer. Greek fire wasn't just a weapon, it was a testament to chemistry's dark artistry, a reminder that some ancient innovations were so potent, their shadows still flicker in our collective memory. In a quiet corner of Yale University's rare book library rests what may be the most confounding artifact ever put to paper: the Voynich Manuscript. This 200-page parchment, carbon dated to the early 15th century, looks like something ripped from the pages of a medieval fantasy. Its pages are crammed with looping, alien handwriting that resembles no known alphabet, accompanied by illustrations of plants that don't exist, nude women bathing in emerald green pools, and celestial charts mapping unknown constellations. For over a century, cryptographers, linguists, and even wartime codebreakers have tried and failed to crack its secrets. The text flows with the rhythmic patterns of language, yet defies every attempt at translation, making it the ultimate literary enigma. What makes the Voynich manuscript so maddening isn't just its unreadable text, it's the precision behind the chaos. Statistical analysis reveals its symbols follow linguistic rules akin to real languages, with word repetitions and sentence structures that suggest meaning rather than random scribbles. In 2014, a team applied advanced AI trained on nearly 400 languages, expecting to uncover hidden patterns. Instead, the algorithm concluded the text structure was closest to Hebrew, but attempts to translate it yielded only gibberish. Other theories propose it's a lost dialect, an elaborate cipher, or even a constructed language meant for initiates of a secret society. Then there are the illustrations, baffling in their own right. Botanists have pored over the manuscript's elaborate flora, none matching any known species. Some pages depict fantastical roots resembling human organs, while others show plants with spiral leaves arranged like Fibonacci sequences. The astronomical sections feature zodiac-like diagrams, but with extra signs and unfamiliar constellations. One recurring image, a series of interconnected tubes and vessels filled with green liquid, has led some to speculate it's an alchemical manual, documenting processes meant to turn base metals into gold or concoct elixirs of immortality. But here's the twist: modern forensic analysis suggests the manuscript might not be a hoax. The ink and parchment are authentic to the 15th century, and the time required to handcraft such an elaborate fake would have been staggering for the era. Even the choice of materials hints at purpose. The parchment was carefully prepared, the ink mixed with intentionality. Someone went to extraordinary lengths to create this, whether as a genuine record or an arcane joke. The greatest clue might lie in what we don't see. Unlike other medieval texts, the Voynich lacks corrections or scribble errors, as if the author wrote fluently in this language. Some researchers argue it could be glossolalia, a stream of unconscious writing, or an early experiment in proto-linguistics. Others, like famed cryptographer William Friedman, theorized it was a medieval form of synthetic shorthand, encoding medical or herbal knowledge for a select few. Yet after decades of supercomputers, frequency analysis, and brute force decryption, the manuscript guards its secrets as tightly as the day it was discovered in an Italian monastery in 1912. Each failed attempt deepens the mystery, leaving us to wonder, was this meant to conceal knowledge, or is it proof of a lost intellectual tradition? The Voynich manuscript doesn't just resist understanding, it challenges our very assumptions about language, science, and the limits of human ingenuity. Every page whispers the same tantalizing question: what if the answer isn't hidden but something we're simply not equipped to see? Standing at the base of the Great Pyramid of Giza, you're confronted by a paradox, a structure so precise, so monumental, it feels like it was dropped onto the desert by some higher power. Yet every stone was placed by human hands over 4,500 years ago without the aid of wheels, pulleys, or iron tools. The numbers alone defy belief: 2.3 million blocks averaging 2.5 tons each, stacked with gaps between them thinner than a credit card. The pyramid's sides align almost perfectly with the cardinal directions, deviating by less than a fraction of a degree. Modern engineers using GPS still struggle to achieve that level of accuracy across such distances. So how did an ancient civilization with nothing but copper chisels and rope accomplish what we'd find challenging today? Let's start with the stones themselves. The outer casing blocks, now mostly gone, were cut from white Tura limestone with such precision that they fit together like puzzle pieces, reflecting sunlight so brightly the pyramid was said to glow. Each block's angles were calculated to interlock, distributing weight so perfectly that earthquakes over millennia have barely shifted them. Some interior chambers contain granite slabs weighing up to 80 tons, equivalent to a space shuttle hauled from quarries 500 miles away. Theories about ramps abound, but none fully explain the logistics. A straight ramp tall enough to reach the top would require more material than the pyramid itself. A spiraling ramp would obstruct measurements needed to maintain the pyramid's near-perfect symmetry. Then there's the mystery of the king's chamber. Its ceiling consists of 9 granite beams, each weighing 50 tons, lifted to a height of 150 feet. No known ramp could support that weight without collapsing. Some researchers speculate the ancients used counterweight systems or even water-filled shafts to float the blocks upward, but no evidence survives. The precision extends beyond brute strength. The chamber's dimensions encode mathematical constants like pi and the golden ratio, suggesting the builders possessed advanced geometrical knowledge centuries before Greece formalized these concepts. Perhaps most baffling is the pyramid's alignment. The sides face true north, south, east, and west with an error margin of just 3/60ths of a degree. Ancient Egyptians didn't have magnetic compasses. They likely used star alignments, but maintaining that accuracy while stacking layers hundreds of feet high would require surveying tools rivaling modern theodolites. Some claim the builders leveraged the pyramid's own shadow or aligned it with the pole star Thuban, yet replicating this feat today using only period-appropriate tools has never been achieved. Modern attempts to recreate pyramid construction techniques only deepen the mystery. When a team tried building a small-scale pyramid using only ancient methods in 1999, they failed to match the precision, resorting to modern tools to correct errors. Another experiment transporting large stones on wooden sledges found that wetting the sand reduced friction, a technique possibly depicted in tomb paintings. But these are fragments of a lost system. The full picture remains elusive, buried beneath layers of speculation. What's often overlooked is the human element. This wasn't just engineering, it was a symphony of logistics, astronomy, and craftsmanship executed by tens of thousands of workers. Recent discoveries of worker settlements reveal they were well-fed artisans, not slaves. Their organizational skills rivaled modern project management, coordinating quarries, transport, and construction with no written records beyond simple tally marks. The pyramids don't just challenge our understanding of ancient technology, they redefine what we thought possible with unity, patience, and raw ingenuity. Every unanswered question whispers the same humbling truth. We may have satellites and skyscrapers, but somewhere in the desert sands lies a forgotten mastery we've yet to reclaim. Tucked away in the basement of Iraq's National Museum lies an unassuming clay jar roughly the size of a grapefruit that could rewrite the history of electricity. Discovered in 1936 near Baghdad, this 2,000-year-old artifact consists of a terracotta vessel, a copper cylinder, and an iron rod suspended inside with an asphalt seal. At first glance, it looks like an ancient storage container, but when German archaeologist Wilhelm Koenig reassembled the pieces, he noticed something startling. Fill it with an acidic liquid like vinegar or grape juice, and the arrangement produces approximately 1 volt of electricity. The implications are staggering. Centuries before Galvani and Volta pioneered modern batteries, did the Parthians or Sasanians stumble upon electrochemistry by accident? The so-called Baghdad Battery sparks fierce debate among scholars. Some argue it was used for electroplating, coating objects with thin layers of gold or silver through electrical currents. Replicas using similar materials have successfully gilded small items, supporting this theory. Ancient Mesopotamians were master metalsmiths, and examples of delicate gold-plated artifacts from the period suggest they had advanced techniques. Could this jar have been part of a larger workshop setup, powering multiple cells in series for stronger currents? Others propose more esoteric purposes. The battery's design resembles vessels found in temples, leading to speculation it played a role in religious rituals. Imagine a priest demonstrating divine power by giving worshippers a mild shock, or using the current to make metal idols vibrate or emit eerie sounds. There are even fringe theories linking it to early medical practices, like pain relief through electrified acupuncture needles. Yet skeptics counter that no wires, electrodes, or electroplated objects have been found alongside these jars. The asphalt seal could simply have preserved scrolls inside from moisture, with the metal components acting as inert storage. Without clear documentation, Mesopotamia's libraries were lost to time. The battery's true function remains an open circuit of possibilities. What's undeniable is the ingenuity behind the design. The choice of materials wasn't random. Copper and iron create a natural potential difference in acidic solutions, while the asphalt prevented short-circuiting. Whether intentional or serendipitous, this combination reveals an empirical grasp of chemical reactions long before their scientific explanation. Modern recreations prove the concept works, but the absence of widespread similar finds suggests it never evolved beyond localized experimentation. Perhaps the knowledge died with its creators or was deemed too unstable to pursue. Standing before this humble jar, you're left with a tantalizing what if. What if ancient workshops had chains of these cells powering rudimentary devices? What if temple ceremonies harnessed electricity centuries before Faraday? The Baghdad Battery doesn't just challenge our timeline of technological progress, it hints at parallel paths of discovery, where sparks of insight flickered briefly before being swallowed by the darkness of forgotten centuries. Every volt it produces today is a whisper from the past, asking us to reconsider how much our ancestors truly knew. Stretching across nearly 200 square miles of Peru's arid Nazca Desert, an ancient canvas of staggering scale awaits, but only if you know where to look. From the ground, the terrain appears as little more than wind-scoured gravel and reddish dust, but ascend just a few hundred feet and the earth itself transforms. Gigantic geometric shapes emerge, spirals, trapezoids, and razor-straight lines running for miles without deviation. Then come the figures: a hummingbird with wings spanning 300 feet, a spider with perfectly proportioned legs, even a whale breaching invisible waters. These are the Nazca Lines, one of archaeology's most mesmerizing puzzles, colossal artworks etched into the desert over 2,000 years ago by a culture that, by all accounts, never left the ground. How did the Nazca people create designs so precise, so vast, they can only be fully appreciated from the air? Modern engineers struggle to replicate their accuracy even with drones and GPS. The lines weren't carved, they were crafted by removing the desert's dark top layer to reveal the lighter substrate beneath, a technique requiring astonishing spatial awareness. Some figures, like the famous astronaut, like being nicknamed the astronaut, perch on near vertical hillsides, their proportions remaining flawless despite the slope. The straight lines defy belief too. Many run perfectly straight for over 15 miles across rough terrain, with less deviation than a modern laser level over the same distance. Attempts to explain their construction often focus on simple tools, wooden stakes and ropes, but the execution reveals far more sophistication. Researchers have found small alignment markers along some lines, suggesting the Nazca used a grid system scaled up from smaller models. Yet, even with this method, maintaining precision across miles of uneven ground would require surveying knowledge rivaling modern engineers. Some theorize they used smoke or mirrors to align points, while others propose they leveraged celestial markers, aligning designs with solstice sunrises or constellations. But no single theory fully accounts for the sheer variety and complexity of the geoglyphs. Modern experiments highlight just how difficult replication would have been. In 2014, a team tried recreating a scaled-down Nazca figure using only period-appropriate tools. Despite careful planning, their lines wavered within just a few hundred feet, succumbing to natural contours. The Nazca, by contrast, adapted to elevation changes seamlessly, adjusting their designs to maintain visual coherence from above, an effect impossible to appreciate without aerial perspective. This raises haunting questions. Did they have access to rudimentary flight like hot air balloons, as some fringe theorists suggest? Or did they develop a form of mathematical projection we've yet to uncover? Beyond the how lies an even deeper enigma, the why. Some argue the lines were ceremonial pathways walked during rituals to invoke rain in the parched desert. Others see astronomical alignments mapping stars or solstice events. A more unsettling theory proposes they were offerings to sky-bound deities meant only to be seen from above. The Nazca's own pottery depicts balloon-like objects, fueling speculation about ritual flight, but no physical evidence survives. What resonates most is the cultural audacity behind these creations. The Nazca didn't just alter their landscape, they engineered it for an audience they'd never meet: future generations, gods, or perhaps even something beyond their own understanding. In a world without satellites or aerial photography, they invested centuries of labor into artworks they could never fully witness. That paradox lingers in every perfectly curved beak of a condor glyph, every unerring line stretching toward the horizon, a testament to human vision so vast it transcends the limits of its time. The desert has preserved their work for millennia, but the true message of the Nazca lines remains just out of reach, etched not only in sand but in the boundaries of what we thought ancient societies could achieve. In the heart of Delhi, surrounded by the ruins of an ancient Gupta-era temple, stands a metallurgical marvel that defies all logic: the iron pillar. Rising 23 feet into the air and weighing over 6 tons, this 1,600-year-old monument doesn't just impress with its size, it baffles scientists with its eerie resistance to rust. In a city where monsoon rains drench the streets for months and humidity hovers relentlessly, the pillar's surface remains smooth, uncorrupted, as if time itself refuses to leave a mark. Modern steel exposed to Delhi's climate begins corroding within years, yet this ancient relic, forged centuries before the Industrial Revolution, shows barely a speck of oxidation after 16 centuries. How did metalworkers from India's Gupta Empire achieve what our best stainless steels struggle to replicate today? The secret lies in the pillar's unusual composition. Unlike modern iron alloys, which rely on chromium for rust resistance, this artifact contains an unexpectedly high amount of phosphorus, nearly 1% of its total mass. This wasn't accidental. Recent metallurgical analysis reveals the pillar's creators deliberately mixed iron ore with charcoal rich in phosphates during smelting, creating a unique protective layer. When exposed to air and moisture, this phosphorus-rich alloy forms a thin, invisible barrier of iron-hydrogen phosphate, a self-healing film that shields the metal beneath. The process is so effective that even microscopic scratches repair themselves over time, much like human skin. What's truly astonishing is that this level of precision predates modern chemistry by over a millennium. The Gupta-era blacksmiths couldn't have known about atomic bonds or oxidation reactions. Instead, their knowledge likely came from generations of empirical observation, noticing how certain ores, when smelted under specific conditions, produced more durable metal. Some scholars suggest the pillar's composition might be linked to ancient Indian metallurgical texts like the Arthashastra, which describe advanced forging techniques. Yet no surviving records detail this exact formula, leaving modern scientists to reverse engineer the process through trial and error. Attempts to recreate the pillar's alloy have yielded mixed results. While adding phosphorus does improve rust resistance, achieving the same flawless durability requires a perfect balance of temperature, cooling rate, and trace elements that we still can't consistently replicate. Modern forgeries either corrode faster or become brittle, lacking the pillar's rare combination of strength and resilience. Even the pillar's surface tells a story of lost artistry. Its distinctive bell-like resonance when struck suggests an intricate internal crystalline structure formed through a forgotten forging technique. Perhaps the most haunting detail is the inscription carved into the pillar's surface, a Sanskrit dedication to the god Vishnu, still legible after 1,600 years. The letters remain crisp, their edges unsoftened by time, as if the metal itself honors the divine message it carries. This union of spiritual symbolism and metallurgical genius captures the essence of ancient innovation, where science and sacred purpose intertwined seamlessly. Standing before the iron pillar, you're faced with a humbling truth. Our ancestors didn't just stumble upon this knowledge. They cultivated it through centuries of meticulous craftsmanship, passing down secrets we've only begun to rediscover. Every uncorroded inch whispers the same provocative question: what other forgotten marvels might still be waiting, hidden in plain sight? Found in the ruins of the Minoan Palace of Phaistos on Crete in 1908, this palm-sized clay disc is one of archaeology's most stubborn enigmas. Roughly the diameter of a dinner plate and baked solid over 3,000 years ago, the Phaistos disc features a spiral of 45 distinct symbols: human figures, birds, fish, even what looks like a beehive, each stamped into the clay with astonishing precision. At first glance, it resembles an ancient comic strip or the world's oldest board game. But what makes it truly extraordinary isn't just the symbols themselves. It's the fact that every mark was pressed into the clay using custom-made stamps, a technique so ahead of its time, nothing like it appears again in history for another 2,000 years. Consider the implications. Movable type printing, often credited to Gutenberg in the 15th century, may have had a Bronze Age predecessor. Each symbol on the disc is flawlessly replicated, suggesting the Minoans crafted individual punches for every glyph, arranging them in a specific order to convey meaning. Yet, unlike Gutenberg's press, no other stamped texts from this era have ever been found. Was this a one-off experiment, a secret cipher, or evidence of a lost writing system that vanished when the Minoan civilization collapsed? Deciphering the disc's purpose is like trying to solve a puzzle with half the pieces missing. Linguists have analyzed the symbol's arrangement, noting that certain combinations repeat in a way that resembles syllabic writing, perhaps an early form of Linear A, the still undeciphered script used by the Minoans. Others argue the symbols are purely pictographic, representing concepts rather than sounds. One controversial theory suggests it's a musical score, with the spiral guiding a performer through notes or rhythms. Then there's the religious angle. Some symbols mirror artifacts found in Minoan shrines, hinting at a ritual object meant to invoke deities or chart celestial events. The mystery deepens when you examine the disc's physicality. The clay was carefully smoothed before stamping, then fired at a controlled temperature to preserve the impressions. Whoever made this wasn't doodling, they were executing a deliberate, technically sophisticated process. Recent three-dimensional imaging reveals subtle variations in stamp depth, suggesting the artisan adjusted pressure for clarity. Yet the absence of fingerprints or tool marks indicates an almost industrial precision, as if the creator had a system we've yet to reconstruct. Modern attempts to recreate the disc only highlight how advanced the original was. Experimental archaeologists have tried carving replica stamps from wood, bone, and bronze, but matching the crispness of the ancient glyphs requires tools harder than the clay itself, something the Minoans shouldn't have possessed. The disc's perfect symmetry also defies explanation. The spiral maintains consistent spacing despite curving inward, a geometric feat difficult to achieve without measuring instruments. Some speculate the stamps were mounted on a rotating device, like an early printing wheel, but no such mechanism has been found in Minoan digs. What lingers most is the disc's isolation. If this technology existed, why hasn't more turned up? Was it reserved for sacred texts that crumbled to dust, or did the knowledge die with its creators, leaving behind a single tantalizing clue? The Phaistos disc doesn't just challenge our timeline of human innovation, it dares us to reconsider what ancient minds were capable of. Every stamped symbol is a whisper across millennia, asking us to listen harder, look closer, and admit that some secrets refuse to be unearthed. High in the Andes, overlooking the ancient city of Cusco, the stone walls of Sacsayhuaman stand as a silent challenge to everything we think we know about prehistoric engineering. These aren't just walls, they're a gravity-defying puzzle, built from massive limestone blocks, some weighing over 100 tons, fitted together so tightly you can't slide a razor blade between them. The precision is otherworldly. Each stone curves and angles in ways that suggest the builders didn't just place them, they sculpted them like clay, molding edges to interlock in 3 dimensions without mortar. Modern engineers using laser-guided tools struggle to achieve this level of seamless joinery, yet the Inca accomplished it over 500 years ago with nothing but stone hammers and bronze chisels. How did they do it? The conventional explanation involves patient grinding, rubbing stones together with sand and water until they fit. But recent experiments reveal a flaw in this theory. Shaping a single sacsayhuaman block this way would take a team months, yet the site contains thousands. Even more perplexing is the transportation. These stones were quarried miles away, across rugged terrain at 12,000 feet above sea level. Without wheels or draft animals, the Inca supposedly dragged them using ropes and logs. But when a National Geographic team tried replicating this in 2012, they couldn't move a 1-ton replica more than a few feet before the rope snapped. The idea of maneuvering 100-ton blocks up mountain paths becomes almost farcical. The wall's true genius, however, lies in their seismic resilience. Peru sits on the volatile Pacific Ring of Fire, yet Sacsayhuaman has withstood centuries of earthquakes that flattened modern buildings nearby. The secret. The stone's irregular shapes create flexible joints that shift during tremors before settling back into place, a concept modern architects call a seismic construction. Japan's skyscrapers now use similar shock-absorbing designs, but the Inca achieved it through intuition, not physics textbooks. Some researchers believe they mimicked natural formations, observing how fractured bedrock interlocked after quakes. Others point to the wall's slight inward tilt, dispersing seismic energy upward like a pyramid. Then there are the mysteries no theory explains. Many stones feature bizarre knobs and protrusions. Some suggest these were handles for lifting, but their placement often defies practical use. More haunting are the perfectly drilled holes in certain blocks aligned with celestial events. During solstices, sunlight pierces them like a sundial, hinting at an astronomical function beyond mere fortification. Spanish chroniclers wrote that the Inca claimed the walls were built by those who came before, fueling speculation about lost technologies or even extraterrestrial influence. Modern attempts to reconstruct Sacsayhuaman's techniques end in frustration. In 2018, engineers using diamond-tipped saws and digital modeling tried replicating a single corner joint. The result, gaps 3 times wider than the originals. The Incas' methods remain locked in the past, a reminder that some forms of knowledge aren't just lost, they're untranslatable to our modern mindset. Perhaps the walls weren't just built to last, they were built to teach us humility, stone by impossible stone. Lost in the foggy expanse of the North Atlantic, Viking ships somehow charted treacherous courses with eerie precision, reaching Greenland, Iceland, and even North America centuries before Columbus. Their secret, a legendary tool mentioned in sagas but long dismissed as myth, the solarstein or sunstone. This wasn't some magical artifact. According to researchers, it was an ingenious navigational crystal that could pinpoint the sun's location even through dense cloud cover or the endless twilight of Arctic summers. Forget compasses, this low-tech marvel relied on the physics of light itself, and we're only beginning to understand how it worked. The key lies in a peculiar property of certain crystals like Iceland spar, a transparent calcite that splits light into 2 beams. When rotated, the crystal's intensity shifts based on the sun's hidden position, creating telltale brightness patterns. Viking navigators likely held the stone to the sky, turning it until both light beams matched, revealing the sun's direction to within a single degree. Laboratory tests prove its startlingly effective. Modern pilots using replica sunstones in overcast conditions can locate the sun almost as accurately as GPS. Yet mysteries linger. No sunstone has ever been found aboard a Viking wreck, leaving archaeologists to piece together clues from scattered references. The 13th century saga of Saint Olaf describes sailors using the stone to confirm the sun's location during a snowstorm, while other texts hint at its use alongside twilight boards, wooden discs that may have helped calculate latitude. What's baffling is why this technology vanished. Even today, with all our satellites and radar, sailors navigating polar regions face deadly, white-out conditions where traditional compasses fail. A simple, battery-free solution like the sunstone could save lives, yet modern maritime training ignores it entirely. Perhaps the answer lies in the Vikings' unique relationship with their environment. Their navigational prowess wasn't just about tools, it was a symphony of observation, blending wave patterns, bird behavior, and even the color of seawater with the sunstone's readings. The crystal didn't work alone. It was part of a holistic system we've yet to fully reconstruct. That's the true lesson of the sunstone. Sometimes the most advanced technology isn't the one with the most circuits, but the one that listens closest to the natural world. Deep within the temple of Hathor at Dendera, a series of enigmatic carvings crawl across the ancient stone, images so startlingly modern they've ignited debates for decades. One particular relief shows what appears to be a giant light bulb, a filament-like snake winding through an elongated glass bulb, supported by a pedestal that resembles an electrical insulator. To the untrained eye, it could pass for an ancient blueprint of a Crookes tube, an early light-emitting device. This is the so-called Dendera light, a controversial interpretation that suggests the Egyptians may have harnessed electricity thousands of years before its official discovery. Proponents of the theory point to eerie details. The bulb encloses a wavy serpent echoing the zigzag pattern of electrical discharge, while a cable dangles from its base, terminating in what looks like a socket. Nearby figures appear to manipulate the device, their poses mirroring technicians maintaining delicate equipment. Even more compelling, the temple's subterranean crypts, where these carvings are concentrated, show no traces of soot or oil stains, unexpected for chambers supposedly lit by torches or lamps. Could these reliefs document a lost form of illumination, powered by primitive batteries like the Baghdad artifact? Mainstream archaeologists, however, counter with a very different reading. They identify the bulb as a symbolic representation of the Jed pillar, a sacred emblem of stability cradling a lotus flower from which the snake deity Harsomptus emerges. In this context, the scene depicts a cosmic creation myth, not a technical manual. The filament symbolizes the serpent of chaos, Apep, being tamed by divine order, while the socket represents a ceremonial vase. As for the soot-free crypts, scholars suggest reflective metal plates could have redirected sunlight through cleverly placed shafts, a technique found in other Egyptian structures. Yet even this explanation leaves gaps. Why choose such an uncanny visual metaphor? Other temple reliefs depict myths using straightforward iconography, gods with animal heads, stars as five-pointed shapes. The Dendera carvings stand apart in their eerie specificity. Modern reconstructions show that if the bulb were hollow and filled with gas, an electric charge could indeed make the inner serpent appear to glow, an effect that would have seemed miraculous to ancient observers. Could this be a case of sacred art preserving lost science through symbolism? The debate crystallizes a broader tension in archaeology: how to interpret ancient imagery when our modern biases color what we see. The light bulb theory risks projecting contemporary technology onto sacred art, yet dismissing it outright ignores the Egyptians' documented ingenuity with chemistry and engineering. Perhaps the truth lies in between, not a literal light bulb, but a sophisticated understanding of natural phenomena expressed through myth. After all, the same culture that aligned pyramids with stars might have discovered and ritualized principles of static electricity or bioluminescence we've yet to uncover. What lingers isn't just a question of technology, but of perspective. the Dendera reliefs challenge us to consider how much ancient knowledge might be hiding in plain sight, disguised as myth because we lack the framework to recognize it as science. Whether a sacred symbol or a lost invention, these carvings glow with the same haunting message. Sometimes the past refuses to be easily decoded. Scattered across the river deltas and jungles of Costa Rica, over 300 perfectly spherical stone orbs lie half buried in the earth, some as small as grapefruits, others towering taller than a person and weighing over 16 tons. Carved by a vanished pre-Columbian civilization known as the Diquis people between 600 and 1500 years ago, these spheres aren't just artifacts, they're geometric impossibilities. Each one achieves a level of roundness that would challenge modern sculptors with laser-guided tools, yet they were shaped entirely by hand, using nothing but stone hammers and abrasives. The precision is mind-bending. Advanced measurements reveal deviations of less than 2 millimeters from perfect sphericity on the largest specimens. How did a culture without written language or metal tools accomplish what engineers today would consider a machining marvel? The mystery begins with the stone itself. Most spheres were carved from gabbro, a volcanic rock as hard as granite, or limestone from distant quarries. Archaeologists initially hypothesized that artisans pecked them roughly into shape before polishing with sand, but experiments show this method leaves telltale pockmarks, scars absent on the originals. Instead, the Diquis likely employed a revolutionary technique, heating the stone with fire before rapidly cooling it with water, causing flakes to shear off in controlled layers. This thermal shock method, combined with relentless grinding using quartz sand, could explain the flawless curves. Yet even with these insights, modern attempts to replicate the process take months per sphere, while evidence suggests the Diquis produced them by the hundreds. Purpose is another enigma. Some spheres rest in alignment with celestial events, suggesting astronomical functions. One cluster near the Rio Taroba mirrors the Pleiades constellation during equinoxes. Others appear arranged in geometric patterns, possibly as boundary markers for sacred sites or elite residences. Spanish colonial accounts mention spheres flanking pathways to chiefdoms, hinting at status symbols. But the most tantalizing clue comes from their distribution. Many were found perched atop man-made mounds, precisely positioned to remain visible across great distances. Were they territorial markers, cosmic calendars, or perhaps something more profound, physical manifestations of the Diquis' belief in celestial harmony, where perfect spheres symbolized the eternal balance of the universe? The tragedy lies in what's been lost. Many spheres were dynamited in the 1930s by treasure hunters convinced they held gold, while others were rolled into rivers or bulldozed during farming. The few undisturbed sites reveal intricate groupings, triangles, straight lines, even parabolic curves that suggest mathematical intent. One theory posits they functioned as a massive land survey system, their alignments encoding geographical knowledge. Another notes their resemblance to the sky stones of Mesoamerican cultures, used to predict solstices. Today, these silent stone sentinels guard their secrets fiercely. Modern laser scans detect no tool marks, only the faintest whisper of human touch worn smooth by centuries. The Diquis left no blueprints, no legends, just these implausibly perfect orbs scattered like marbles tossed by giants. Each one is a silent challenge to our assumptions about pre-industrial societies, proof that precision and artistry need not wait for modern technology. They remind us that some questions resist answers, that the past keeps its mysteries closer than we think, and perhaps that's their true purpose, not to be solved but to humble us. Nearly 2 millennia before modern seismographs, a Chinese polymath named Zhang Heng unveiled a device that seemed to defy the limits of his era, a bronze vessel adorned with 8 dragon heads, each clutching a metal ball above the open mouths of corresponding toads. This was no ceremonial ornament. In the year 138, this invention, known as the seismoscope, detected an earthquake over 300 miles away from the imperial capital, while the ground beneath the emperor's court remained still. Court officials initially dismissed the alert until messengers arrived days later confirming tremors in the distant province. The implications were staggering. For the first time in history, humanity could listen to the Earth's hidden movements long before the ground began to shake. What made Zhang Heng's seismoscope so revolutionary was its apparent simplicity masking profound ingenuity. Ancient texts describe an inverted pendulum hidden within the vessel, a central column suspended like a chandelier, free to sway when seismic waves rippled through the Earth. Each dragon's mouth connected to delicate internal levers, calibrated to release its ball when the pendulum swung in a specific direction. The falling ball not only signaled an earthquake but also pointed toward its origin. Modern engineers marvel at the elegance of this system, a mechanical algorithm for decoding the Earth's vibrations, built centuries before the science of seismology existed. Yet reconstructing the device has plagued researchers for decades. When a team from the Chinese Academy of Sciences built a replica in 2005, they discovered a perplexing gap between historical accounts and physical reality. The seismoscopes described sensitivity detecting quakes up to 400 miles away shouldn't have been possible with pendulum mechanics alone. Some speculate Zhang Heng exploited harmonic resonance, tuning the pendulum to oscillate at frequencies matching distant tremors. Others propose hidden mercury channels amplified subtle movements, a theory supported by the philosopher's writings on liquid dynamics. The closest working model, developed in 2017, incorporates a hybrid of pendulums and inertial sensors, yet still falls short of the original's legendary precision. The true enigma lies in the lost craftsmanship. Zhang Heng's original was cast using lost wax bronze techniques so precise, the internal mechanisms remained hermetically sealed, a deliberate design choice to protect trade secrets. No detailed schematics survive, only poetic allusions in court records. One cryptic passage mentions 8 trigrams aligning with cosmic forces, hinting at connections between the seismoscope and ancient Taoist cosmology. Was the device more than a scientific instrument? Some scholars argue its design mirrored the I Ching's philosophy, where earthly events reflected celestial patterns. Perhaps the most haunting lesson of the seismoscope is how knowledge ebbs and flows across centuries. While modern seismographs outperform it technologically, they rely on electricity and digital networks infrastructure vulnerable to the very disasters they predict. Zhang Heng's creation required nothing but gravity and bronze, a self-contained warning system that functioned independent of external power. In an age increasingly aware of civilization's fragility, his invention whispers a provocative question: have we truly advanced or merely exchanged one form of wisdom for another? The dragons still wait, silent and vigilant, for the next tremor only they can foresee. Buried in Viking graves and medieval battlefields across Europe, a handful of swords stand apart from the rest, marked with a name that echoes through history: Ulfbert. These 9th century blades weren't just weapons, they were masterpieces of metallurgy so advanced they rival modern steel. While most Viking swords were brittle, prone to shattering like glass in battle, Ulfbert blades flexed and snapped back into shape, their edges staying sharp through combat after combat. The secret: steel so pure it contains almost no slag, the impurities that weaken most Iron Age weapons. In fact, the carbon content in these blades matches that of high-grade industrial steel produced centuries later. So how did Dark Age blacksmiths achieve a quality that wouldn't become standard until the Industrial Revolution? The answer lies in the crucible, literally. Unlike typical Viking swords forged from bloomery iron, a messy process yielding metal riddled with imperfections, Ulfbert steel was made through a far more sophisticated method called crucible steelmaking. Evidence suggests the raw material came not from local mines, but from distant trade networks stretching all the way to Persia or India. There, artisans heated iron ore with precise amounts of carbon in sealed clay crucibles, melting it at temperatures exceeding 1,500 degrees Celsius. The result was a homogeneous, high-carbon steel ingot, a material so rare and valuable, it likely traveled thousands of miles before reaching the workshops of Frankish or Viking swordsmiths. But here's what truly baffles historians: the Ulfbert signature itself. Over 170 swords bearing this name, spelled +VLF Bur +T, have been found, spanning 200 years and multiple regions. The consistency is staggering. Each inscription is flawlessly executed, suggesting these weren't random forgeries but products of a tightly controlled guild or school. Yet no workshop ruins or written records explain how this knowledge persisted across generations, only to vanish abruptly around the year 1000. Some scholars speculate the Ulfbert lineage traces to a single master smith or monastery, guarding the technique like a trade secret. Others point to the collapse of trade routes during the Middle Ages, cutting off access to the exotic ores needed for the recipe. Modern attempts to recreate these blades reveal just how precise the original process was. Even with today's tools, replicating the exact balance of carbon and trace elements proves maddeningly difficult. Too much carbon makes the steel brittle, too little leaves it soft. The originals hit a Goldilocks zone of purity, around 1.2% carbon, with a crystalline structure that suggests careful tempering at precise temperatures. Some experiments indicate the swords might have been quenched in organic materials like urine or blood, altering the metal's molecular arrangement for unmatched resilience. What's most haunting isn't just the craftsmanship, it's the shadow of what else might have been lost. The Ulfbert swords represent a fleeting peak in medieval metallurgy, a technological dead end that wouldn't be rediscovered for nearly a millennium. Each one is a silent testament to a time when trade routes carried not just goods, but ideas, when the right combination of global knowledge and local skill could produce something centuries ahead of its time. Today, these blades gleam in museum cases, their inscriptions still legible, their edges still sharp, whispering a question that lingers like the ring of steel. How many other breakthroughs from the past have we yet to find? High in the remote mountains of China's Qinghai province, an odd discovery has puzzled explorers and scientists alike: a scattering of hollow, rusted metal pipes embedded deep within solid rock. Known as the Bagong pipes, these strange formations protrude from the sides of Mount Bagong like the remnants of some long-abandoned industrial complex. Some stretch vertically into the mountain's caverns, while others plunge horizontally into the nearby Tosan Lake, their ends corroded but still perfectly round. The question is simple: how did these metallic tubes, some measuring up to 16 inches in diameter, end up lodged in rock formations estimated to be 5 million years old? At first glance, the Bagong pipes seem like the ruins of an ancient metalworking operation. Their composition, iron oxide, silicon dioxide, and calcium oxide, matches materials found in modern smelting byproducts. Even more intriguing, some pipes contain traces of rare earth elements, suggesting advanced metallurgical knowledge beyond anything attributed to early human civilizations in the region. Local legends speak of an advanced race that once inhabited the area, leaving behind these artifacts as proof of their technological prowess. Could these really be remnants of a lost industry forgotten by history? Skeptics argue that the pipes are simply the result of natural geological processes. Certain types of sedimentary rock can form tubular structures when mineral-rich water flows through crevices, depositing iron and other metals over millennia. Known as iron concretions, these formations are found worldwide, often appearing unnaturally symmetrical. But what complicates the Bagong case is the staggering number of pipes. Dozens have been catalogued, clustered in patterns that seem almost deliberate. If natural, why do some run perfectly parallel? Why do others branch off at right angles, mimicking modern plumbing or ventilation systems? Adding to the enigma are the depths at which some pipes were found. Explorers have reported discovering buried sections extending hundreds of feet into the mountain, far beyond where erosion would expose them. Laboratory analysis has dated the rust to at least 150,000 years, long before any known human civilization could have produced such refined metalwork. Some researchers speculate that extreme heat or volcanic activity might have accelerated rusting, skewing the dates. Others wonder if we're looking at evidence of a prehistoric industrial society, one that mastered metallurgy long before Mesopotamia or ancient Egypt. What's perhaps most fascinating is the lack of any nearby infrastructure. Unlike known ancient smelting sites, which are littered with slag heaps, tools, or settlements, the Bagong pipes stand alone. No kilns, no workshops, no shards of pottery or signs of human activity, just these eerie metallic conduits jutting from the earth. If they were man-made, what purpose did they serve? Some theories suggest a massive geothermal system harnessing the mountain's heat for energy. Others propose they were part of an ancient astronomical observatory aligned with celestial events. Modern attempts to explain the Bagong pipes only deepen the mystery. Geologists can't fully replicate their formation under natural conditions, while archaeologists struggle to place them within any known historical context. Each new expedition seems to uncover more questions than answers. Whether the work of nature or a forgotten civilization, these rusted relics force us to reconsider the limits of both geology and human ingenuity. They stand as silent sentinels, whispering of possibilities we've yet to understand. On the remote volcanic slopes of Rapa Nui, towering stone sentinels stand frozen mid-stride, their blank eyes staring inland as if halted mid-journey. These are the moe, the iconic statues of Easter Island, and their existence poses one of archaeology's most stubborn riddles. Carved from compressed volcanic ash, some weigh over 80 tons and stretch 30 feet tall, equivalent to stacking 4 pickup trucks vertically. Yet these colossal figures weren't erected where they were quarried. They were somehow transported miles across uneven terrain by a society with no wheels, no draft animals, and no metal tools. So how did the Rapa Nui people accomplish this feat? The answer might lie in a radical theory that turns engineering assumptions upside down literally. For decades, researchers assumed the islanders used log rollers or sledges to drag the moe horizontally, a method employed by other ancient cultures. But experiments revealed fatal flaws. The island's soft volcanic soil would have collapsed under such concentrated weight, leaving trenches that don't match archaeological evidence. Worse, Rapa Nui's limited tree cover makes the idea of log rollers implausible. Deforestation likely happened after statue transport, not before. Then, in 2012, an unconventional hypothesis emerged. What if the statues walked? Archaeologists Terry Hunt and Carl Lipo proposed the moe were moved upright, rocked side to side like a refrigerator being inched forward. Teams would have used ropes anchored at the statue's base and head, pivoting it forward with each rhythmic tug. When tested with a concrete replica, the method worked. With just 18 people, researchers maneuvered a 10-ton moe forward hundreds of feet in under an hour. The statue's design supports this. Curved bases allowed controlled rocking, while forward-leaning torsos counterbalanced the motion. Even the island's oral traditions hint at this technique, describing the moe walking with divine assistance. But skeptics highlight gaps in the theory. Upright transport would have required perfectly coordinated teams. One misstep could send an 80-ton statue crashing downhill. Damage patterns on fallen moe suggest some did topple during transit, yet the majority arrived intact. Hunt and Lipo argue the statue's D-shaped bases acted like keels, stabilizing them mid-rock, but critics note this wouldn't prevent lateral collapses on steep slopes. Another wrinkle, the island's roads aren't flat but slope upward toward the platforms where moe were erected. Moving them uphill in this manner seems almost suicidally precarious. Perhaps the truth blends multiple methods. Recent soil analysis reveals ancient roads were paved with crushed red scoria, creating a surprisingly smooth surface. Some sections show parallel grooves that might have guided sledges not for dragging, but for stabilizing upright moai during their walk. Others suggest teams switched techniques based on terrain, rocking on flats, pivoting around turns, and even laying statues prone for short lifts over obstacles. This adaptability would explain why moai bases show varying wear patterns, some polished smooth, others scarred by friction. The most haunting clue: dozens of moai lie abandoned along ancient roads as if frozen mid-step. These fallen giants might not be failures, but snapshots of the process statues deliberately laid down during rest breaks or seasonal halts. Rapa Nui's oral histories speak of mana, a spiritual energy that animated the moai when rituals were performed correctly. Maybe the real secret wasn't just physics, but a fusion of engineering and belief where rhythmic chants synchronized pulls, turning back-breaking labor into sacred ceremony. Modern engineers can replicate pieces of the puzzle, but the full picture remains elusive. Moving one moai is a challenge. Transporting nearly 900, as the Rapa Nui did, borders on miraculous. Each statue that stands today is a testament to a society that refused to be limited by what outsiders deem possible. They didn't just move stone, they made it dance. Across the windswept hills of Scotland and parts of Europe, the ruins of ancient forts hold a secret that defies the laws of nature. Walls of stone fused together like black glass, as if scorched by the breath of a dragon. These are the vitrified forts, structures where massive ramparts have been melted into a solid, glossy mass, with temperatures reaching over 1,000 degrees Celsius hotter than a blast furnace. What force could have transformed solid rock into molten slag, and why would anyone intentionally subject their defenses to such infernal heat? The answers remain as elusive as the people who built these enigmatic strongholds over 2,000 years ago. The process of vitrification is no accident. When certain types of rock, particularly granite or basalt, are exposed to extreme heat, their minerals melt and recrystallize, forming a dense, glass-like crust. To achieve this effect deliberately would require sustained temperatures rivaling those of modern industrial kilns. Yet excavations reveal no signs of massive bonfires or coal deposits capable of generating such heat. Some forts show vitrification only in specific sections, often at the innermost walls, suggesting targeted application rather than wildfire or lightning strikes. Was this a defensive measure, turning ramparts into impenetrable barriers, or does it hint at a forgotten technology lost to time? One prevailing theory suggests these forts were set ablaze during sieges, either by attackers to breach defenses or by defenders in a ritual of destruction, burning their own strongholds to deny them to enemies. But experiments reveal a flaw in this idea. When researchers tried replicating the effect by stacking wood against stone walls and igniting it, the heat barely reached half the necessary temperature. Even with accelerants like animal fat or resin, the stones charred without melting. The ancient builders must have employed a more sophisticated method, perhaps layering combustible materials with mineral catalysts to intensify the flames. Some archaeologists point to the fort's strategic locations, often atop hills with natural wind tunnels, which could have created furnace-like conditions when fires were lit. Yet another possibility is even more intriguing: that the vitrification was intentional from the outset, a form of stone welding meant to strengthen walls against assaults. A handful of ancient texts describe rituals where fire was used to make the walls one, binding stones together through what we'd now call sintering. Could the builders have mastered a technique akin to modern ceramics, where heat fuses particles into unbreakable matrices? The chemistry supports this. Samples from some forts contain traces of alkaline salts, which lower the melting point of silica, allowing vitrification at slightly more achievable temperatures. The most haunting question isn't just how they did it, but why the knowledge was lost. These forts spanned centuries and regions, from Scotland's Tap O North to France's Peyron, yet the practice disappears abruptly from the archaeological record. No later cultures replicated it. Even the Romans, master engineers who encountered these ruins, left no records of understanding their construction. The vitrified forts stand as ghostly anomalies, their blackened stones testifying to a skill we can't reclaim. Modern attempts to unravel the mystery only deepen it. Teams using thermite, a mixture of aluminum and iron oxide, have managed to simulate small-scale vitrification. But the idea that Iron Age people stumbled upon such chemistry stretches credulity. Others suggest the walls might have been packed with peat or coal seams, ignited during attacks to create an impassable moat of heat. But without written accounts or surviving tools, we're left with fragments of a puzzle, glassy, enigmatic, and resistant to interpretation. Stand before one of these forts today, and the air itself seems charged with ancient energy. The vitrified stone glistens oddly in the sunlight, a fusion of geology and human will that refuses to yield its secrets. These walls weren't just built, they were transformed, remade by fire into something beyond ordinary stone. Whether as weapons, rituals, or feats of engineering, they whisper a truth we're only beginning to grasp. The past holds technologies that blur the line between science and sorcery. Buried beneath the ruins of an Assyrian palace in modern-day Iraq, a small, almond-shaped piece of rock crystal sat unnoticed for centuries among treasures of gold and ivory. Discovered in 1850 during excavations at Nimrud, this 3,000-year-old object, now called the Nimrud lens, measures just over an inch in diameter, with one flat side and one slightly convex. At first glance, it could pass for a decorative inlay or a nobleman's trinket, but hold it up to sunlight and something remarkable happens. The crystal bends light with enough precision to magnify objects beneath it. This tiny artifact, no thicker than a credit card, has ignited a debate that shakes our understanding of ancient optics. Did the Assyrians master lens crafting a millennium before the first known telescopes? The lens's design suggests intentional optical use. Its convex surface has a focal length of roughly 4.5 inches, capable of concentrating sunlight or magnifying small text. Microscopic analysis reveals deliberate grinding marks, not random, where someone shaped this crystal with purpose. Assyrian craftsmen were renowned for their intricate seal carvings, some featuring details finer than a millimeter. Could the lens have been a craftsman's tool, allowing them to etch with such precision? Cuneiform tablets from the period describe burning glasses used to start fires, while others mention stones that make the small large, hints that optical manipulation wasn't unknown. Yet skeptics argue the lens may have been ornamental, perhaps set into a scepter or headdress as a symbol of divine sight. Assyrian art abounds with solar imagery, and the crystal's slight magnification could be incidental, a byproduct of polishing rather than intent. The palace where it was found housed countless luxury items, and without context it was uncovered in a storage room, not a workshop. Its purpose remains speculative. But here's the twist. Similar lenses have been found at other Near Eastern sites, including one in Crete dated to 500 years earlier. If decorative, why the recurring convex shape across cultures? The most tantalizing theory posits the lens as part of a larger optical device. Assyrian astronomers meticulously tracked planetary movements, and their star catalogues rivaled those of later Greeks. Could this lens have been paired with others in a primitive telescope? Roman writer Seneca described Nero observing gladiatorial games through an emerald lens, suggesting ancient rulers exploited magnification. Yet no Assyrian artifacts resembling telescope tubes have surfaced, and the lens's small size makes it impractical for celestial observation. Still, even crude optics could explain how astronomers recorded phenomena invisible to the naked eye, like Jupiter's moons. The real enigma isn't whether the lens worked, It's why the technology seemingly vanished. For over 1,000 years, no culture produced comparable lenses until Arab scientists like Alhazen refined optics in the 11th century. One possibility: the Assyrians guarded the technique as a royal secret, lost when their empire fell. Alternatively, lenses may have been rare luxuries, their utility overshadowed by cheaper alternatives like polished obsidian. The Nimrod lens's fragile nature also hints at a practical barrier. Rock crystal is brittle, and surviving specimens might be the exceptions rather than the rule. Modern recreations prove the lens's functionality but deepen the mystery. When optometrists ground a replica using period-appropriate tools, they found its magnification ~1, 5x, ideal for fine engraving or reading cuneiform. Yet its imperfections scatter light, making it useless for precise astronomy. This duality captures the lens's essence, a tool balanced between practicality and mystery, too advanced to dismiss as mere ornament, yet too crude to fit neatly into our technological timeline. Perhaps the most haunting lesson lies in its simplicity. The Nimrod lens required no advanced machinery, just a skilled hand and an observant mind. Its existence whispers that brilliance isn't always about complexity. Sometimes it's about seeing the potential in a piece of crystal and daring to shape it. Whether as a craftsman's aid, a fire starter, or a forgotten step toward telescopes, this little lens refracts more than light. It bends our perception of history itself. In the windswept deserts of China's Tarim Basin, a collection of mummies dating back 4,000 years lies frozen in time, not just in their eerily preserved skin, but in the vibrant fabrics that still cling to their bodies. These aren't the tattered rags you might expect from Bronze Age burials. The Tarim mummies wear woolen textiles so finely woven, so bursting with color and pattern, they wouldn't look out of place in a modern designer's studio. Crimson and indigo stripes run sharp as knife edges across tunics, while intricate plaids and geometric checks showcase a mastery of the loom that rivals anything from medieval Europe. Yet these creations predate the Silk Road by centuries, emerging from a culture that shouldn't have possessed such advanced textile technology. How did a nomadic people living on the fringes of the Taklamakan Desert achieve weaving perfection when the great civilizations of Egypt and Mesopotamia were still producing far cruder fabrics? The answer lies in the threads themselves. Microscopic analysis reveals the Tarim weavers used a twill technique, a complex method where the warp and weft threads interlace in diagonal patterns, creating stronger, more flexible cloth. This same weave would later make Viking sailcloth legendary and denim jeans indestructible, but here it appears millennia ahead of schedule. Even more baffling is the dye chemistry. These fabrics retain shocking blues, deep reds, and earthy ochres despite 4,000 years of burial, thanks to mordants, metallic salts that fix dyes permanently to fibers. Europe wouldn't develop comparable dye-fast techniques until the Renaissance. Some garments even feature woven-in decorative elements like braided cords and tassels, suggesting an almost obsessive attention to detail. What truly staggers archaeologists is the contrast with contemporaneous textiles. While Egyptian mummies of the same era were wrapped in simple linen sheets, the Tarim people wore tailored clothing with functional design elements, fitted sleeves, reinforced seams, and even what appear to be early forms of embroidery. One child's mummy sports leggings woven with stretch-friendly loops, a precursor to elasticated fabric. Another wears a felted wool hat with ear flaps, its edges trimmed with decorative stitching that still lies perfectly flat. This wasn't just utility, it was haute couture of the Bronze Age. The mystery deepens when we consider the tools available. No advanced looms have been found at Tarim sites, just simple wooden frames that shouldn't produce such intricate work. Modern weavers attempting to replicate the fabrics using period-accurate equipment report it's nearly impossible without additional tensioning devices or heddles, components that leave no archaeological trace. Some speculate the weavers used a lost technique involving weighted threads or specialized bobbins, while others suggest the dry desert air played a role in preserving details that would normally degrade. Perhaps most intriguing is what these textiles reveal about cultural connections. The plaids resemble those of ancient Celtic tribes, while the twill weaving mirrors Scandinavian methods. Yet the Tarim Basin was geographically isolated, surrounded by mountains and deserts. Could these techniques have spread along some forgotten trade route, or did multiple cultures independently arrive at the same solutions? The mummies themselves add to the enigma, their European-like features suggesting migrations were only beginning to map. Standing before these fabrics in a museum today, what strikes you isn't just their beauty but their defiance of time. The indigo hasn't faded, the stitches haven't unraveled, the woven patterns still align with mathematical precision, as if the weavers somehow bound their skill into the very fibers. In a world obsessed with technological advancement, the Tarim textiles whisper a humbling truth. Sometimes the most enduring innovations aren't the loudest or the biggest, but those crafted quietly by hands that understood their materials intimately. Every surviving thread is a challenge to our assumptions about progress, proving that refinement isn't always about what comes next, but about how deeply you can master what's already in your hands. High on the windswept plateau of Bolivia's Altiplano, a single carved archway stands as the sole remnant of a civilization that mastered time itself. The Sun Gate of Tiwanaku, hewn from 10 tons of solid andesite, is more than just a monument, it's a celestial clock. Etched across its surface, intricate carvings of winged figures and geometric patterns hide an astonishing secret. A complex calendar system capable of tracking solstices, equinoxes, and even the 18-month agricultural cycles of the Andes with pinpoint accuracy. What makes this ancient almanac so extraordinary isn't just its precision, but the fact that it predates the Inca by centuries and rivals the astronomical prowess of far more advanced cultures halfway across the world. At first glance, the gate's central figure, often called the staff god, appears to be a static deity surrounded by lesser figures, but researchers have discovered these surrounding carvings function as a sophisticated ephemeris, marking key astronomical events through symbolic alignments. On the winter solstice, sunlight strikes notches along the gate's upper right quadrant, casting shadows that perfectly intersect with carved lines pointing to the sunrise position on the horizon. During equinoxes, shadows from protruding stone knobs bisect the staff god's headdress, signaling the balance of day and night. These aren't rough approximations. Measurements show the alignments deviate by less than half a degree from true astronomical events, a margin of error that would challenge modern surveyors working without GPS. The true genius of the calendar lies in its adaptability. Unlike rigid European systems, the Tiwanaku method accounted for the Andean ecological calendar, dividing the year into 27 and 33-day months based on crop cycles and animal migrations. Faint secondary carvings, only visible at certain angles of sunlight, appear to mark the heliacal rising of the Pleiades, a star cluster critical to predicting seasonal rains. Recent laser scans revealed even subtler grooves that may have tracked the 18-6-year lunar standstill cycle, a phenomenon many ancient cultures missed entirely. How did a society without written records or metal tools encode such nuanced astronomical knowledge into stone? Archaeoastronomers have spent decades trying to reverse engineer the gate's logic. Experiments with replica gates show the carvings only align correctly when positioned at Tiwanaku's exact latitude, proving the design was hyper-localized, not copied from elsewhere. The gate's location also plays a role. Situated between two sacred mountains, it forms a natural horizon calendar. On key dates, the sun rises directly behind Mount Kimsachota, its silhouette interacting with the gate's carvings like the hands of a colossal clock. This fusion of monumental architecture and natural landmarks suggests the Tiwanaku didn't just observe the skies, they wove timekeeping into the very landscape. Yet the most baffling aspect isn't the calendar's complexity, it's the tools used to create it. Andesite is harder than granite, yet the gate's carvings show no chisel marks, only smooth, polished curves that suggest the use of abrasives or even sonic tools lost to history. The precision is so exact that when the gate was accidentally moved in the early 20th century, the alignment stopped working until researchers painstakingly restored its original orientation to within fractions of a degree. Modern engineers struggle to explain how builders without theodolites or magnetic compasses achieved such perfection. What haunts researchers is the realization that this gate was likely just one piece of a larger system. Fragments of similar carved stones found nearby hint at a network of astronomical markers, possibly spanning the entire city. The Tiwanaku's descendants, the Inca, famously used pillars called sucancas for solstice tracking, but their methods were crude compared to the gate's embedded calculus. This wasn't just a calendar, it was a stone-bound archive of celestial mechanics, a bridge between Earth and sky that modern science is still struggling to cross. Every shadow it casts, every alignment that still holds true after 1,000 years, is a silent challenge to our assumptions about ancient knowledge, proof that some civilizations measured time not in years, but in the imperceptible drift of stars. In the sacred halls of India's Lepakshi temple, a single pillar defies the laws of physics, hanging suspended in midair, its base hovering a full inch above the stone floor. This isn't an illusion or trick of the light. Carved from a single block of granite during the 16th century Vijayanagara Empire, the Akasa Estambha, or sky pillar, supports the weight of the entire roof structure while maintaining its impossible gap, leaving pilgrims and engineers alike grasping for explanations. How does a structure designed to bear immense loads float above its foundation? The answer lies in a forgotten fusion of acoustics, geometry, and spiritual symbolism that modern architects are still struggling to replicate. At first glance, the pillar appears identical to its 49 grounded counterparts, covered in intricate carvings of deities, dancers, and mythical beasts. But crouch down and you can slide a thin cloth or even your hand beneath its base, proving it never touches down. The secret isn't magic, it's meticulous weight distribution. The pillar actually connects to the ceiling through a series of interlocking stone brackets, transferring its load upward rather than downward. This counterintuitive design acts like an inverted pendulum, with the pillar's own weight and the roof's compression balancing each other perfectly. Modern engineers confirm the calculations would require an understanding of center of mass physics centuries ahead of its time. Yet the true marvel isn't just structural, it's musical. Tap the pillar gently and it resonates with a metallic hum unlike any other stone in the temple. Archaeologists discovered this acoustic anomaly stems from hollow channels carved inside the pillar's core, turning it into a giant wind chime that amplifies specific frequencies during rituals. These vibrations may have served a dual purpose, masking distant sounds for private ceremonies while creating an otherworldly ambience that enhanced spiritual experiences. When British engineers attempted to relocate the pillar in the 1920s, they found it emitted eerie harmonics at certain angles, proof its builders calibrated it to the temple's exact dimensions. The pillar's construction reveals even deeper sophistication. Its surface carvings aren't merely decorative, they disguise hairline cracks that act as expansion joints, allowing the granite to shift minutely during temperature changes without fracturing. Microscopic analysis shows the base was polished with a unique abrasive mixture containing diamond dust, creating a surface so smooth that air pressure alone helps maintain its hover. Most astonishingly, the entire temple complex is aligned so that during equinoxes, sunlight strikes the pillar's shadow at precise angles, casting a silhouette that measures time like a sundial. Modern attempts to recreate the hanging pillar end in frustration. In 2019, a team from IIT Madras built a scaled replica using traditional tools. Despite precise measurements, their pillar either sank into the base or destabilized the roof structure. The original builders likely employed a trial and error process, adjusting the ceiling brackets grain by grain until equilibrium was achieved, a patience modern construction schedules can't afford. What lingers isn't just the how, but the why. Local legends say the pillar was left slightly unfinished to symbolize humanity's eternal incompleteness before the divine. Others claim it represents the mythological axis mundi, a bridge between earthly and celestial realms. Whatever its purpose, the pillar stands as both an engineering triumph and a philosophical riddle, proof that some ancient technologies weren't just about solving problems but transcending them. Every hovering inch whispers the same truth: gravity isn't the only force that binds us. Beneath the quiet farmlands of Zhejiang province in China, a labyrinth of staggering scale lies hidden. The Longyu Caves, a network of 24 hand-carved caverns so vast and meticulously engineered, they defy every assumption about ancient labor and technology. Discovered in 1992 when a curious villager drained a local pond, these subterranean chambers reveal walls covered in uniform chisel marks, arched ceilings soaring nearly 100 feet high, and pillars positioned with structural precision, all hewn from solid sandstone over 2,000 years ago. The sheer volume of rock removed equals roughly 900,000 cubic meters, enough to fill 300 Olympic swimming pools. Yet no historical records mention their construction, no tools have been found nearby, and no soot stains from torches mar the ceilings. Who carved these caverns, why, and how did they achieve such geometric perfection in near-total darkness? The walls alone are a puzzle that scrambles conventional timelines. Every surface is covered in parallel grooves, each precisely 60 degrees apart, as if made by a machine. Modern engineers confirm this pattern isn't just decorative, it's structurally optimal for distributing weight and preventing collapse, a technique modern tunnel boring machines replicate with rotating drill heads. Yet these grooves show no tool slippage or variation, suggesting an almost assembly line consistency. Experiments with replica bronze chisels show the markings could only be made by applying equal force at the exact same angle, thousands of times in perfect repetition. Even with teams working in shifts, the labor would have required decades, yet the caves show no signs of abandoned work or phased construction. It's as if they were carved in a single, uninterrupted effort. Then there's the acoustics. Certain chambers amplify sound in ways that seem deliberate. Clap your hands near a pillar in Cave 1, and the echo returns as a clear musical tone, an effect seen in ancient Greek amphitheaters but unheard of in enclosed Chinese spaces from this era. Researchers from Zhejiang University found the cave's resonant frequencies align with traditional Chinese musical scales, hinting at ritual or ceremonial use. But if that's true, why are there no artifacts, no inscriptions, not even a single pottery shard to suggest human occupation? The floors are unnervingly clean, as if the caves were sealed immediately after completion. The most haunting mystery isn't the how but the why. Unlike the quarry caves of Egypt or the catacombs of Rome, these tunnels serve no obvious purpose. They're too shallow for mining, too symmetrical for storage, and lack the iconography of tombs or temples. Local legends speak of an emperor hiding his army underground, but the cave's tight corridors would have been impractical for troops. Another theory suggests they were an ancient reservoir system, yet the walls show no water erosion. The lack of records is especially jarring given China's meticulous dynastic chronicles. It's as if the project was deliberately erased from history. Modern attempts to reconstruct the construction only deepen the enigma. Using sandstone samples, geologists calculated that removing this much rock would have required over 1,000 workers laboring non-stop for 6 years. But without ventilation shafts, how did they avoid suffocation? Without scaffolding, how did they reach the ceilings? the absence of debris is equally baffling. Millions of tons of excavated stone vanished without a trace, with no mounds or nearby structures built from the material. Perhaps the greatest clue lies in what the caves lack. No soot, no tool fragments, no refuse, just silence and stone. This wasn't haphazard digging. It was a surgical excavation, executed with a precision that borders on reverence. The Longyou caves don't just challenge our understanding of ancient engineering, they force us to confront the possibility of a lost school of craftsmanship, a tradition so advanced, so specialized, it left no fingerprints beyond these echoing, empty halls. Every chisel mark is a whisper from the dark, asking us to reconsider what humans are capable of when driven by purposes we've yet to fathom. At the windswept highlands of Bolivia, near the shores of Lake Titicaca, the ruins of Pumapunku stand as a shattered monument to engineering so precise, it seems cut by lasers rather than ancient hands. Unlike the rough-hewn stones of most prehistoric sites, these granite and andesite blocks feature razor-sharp edges, flawless right angles, and interlocking channels so exact that modern architects struggle to explain their construction. The stonework here doesn't just defy the era's assumed technology, it mocks it. Take one particular slab known as the H-block. Weighing nearly 8 tons, this andesite monolith has recessed notches and protrusions that fit together with other stones like pieces of a 3D puzzle. The grooves are so meticulously parallel, they maintain a consistent width of exactly 5 millimeters across their entire length, a tolerance achievable today only with computer-guided diamond saws. Even more baffling are the drill holes found in some blocks, perfectly cylindrical and indistinguishable from those made by modern tungsten carbide bits. Yet radiocarbon dating places Pumapunku's construction around 500 AD, over 1,000 years before such tools were supposedly invented. Conventional archaeology suggests the builders used stone hammers and copper chisels. But experiments reveal a glaring problem. Andesite ranks just below diamond on the Mohs hardness scale. Pound it with a stone hammer and you'll shatter the hammer before leaving more than a scratch on the rock. Even copper tools, the hardest metal available to the civilization, would have dulled after minutes of use. Some researchers propose the use of abrasive sand slurry to slowly grind the stone, but this fails to explain the microscopic tool marks visible under magnification, straight grooves suggesting a cutting, not grinding, motion. The precision extends beyond mere geometry. Certain blocks feature complex geometric patterns, chevrons, crosses, and zigzags etched into their surfaces with such uniformity, they appear machine-stamped. When scanned with laser profilometers, these carvings show no tool slippage or variance in depth, implying the artisans used guided templates or even primitive lathes. Yet no such devices have been found in the archaeological record. Even more perplexing are the knob protrusions found on many stones. These aren't decorative, they are functional, designed to anchor ropes or levers for assembly. Each knob is positioned at the exact center of mass for its block, a calculation that would require advanced understanding of physics. Theories attempting to explain Pumapunku's construction range from plausible to provocative. Some scholars suggest the builders employed a lost technique involving high-temperature softening, heating the stone to near melting points before shaping it, but no evidence of large-scale heating exists at the site. Others propose the use of sonic drilling, where vibrations liquefy stone momentarily, allowing tools to pass through like butter. While experimental, this aligns with indigenous legends mentioning tones that made the mountains dance. The most controversial theory points to evidence of vitrification, stone surfaces melted into glassy sheets, hinting at extreme, possibly deliberate, thermal events. What's undeniable is the contrast between Pumapunku and contemporary sites. Nearby Tiwanaku, built by the same civilization, features impressive but comparably crude stonework. It's as if Pumapunku represents a sudden technological leap, or perhaps the last remnants of an even older, forgotten school of engineering. The stones themselves offer no answers, only silent testimony to a craftsmanship that vanished as mysteriously as it appeared. Modern attempts to replicate Puma Punku's precision only underscore the gap between ancient and modern understanding. In 2018, a team of stonemasons using traditional tools and methods failed to reproduce even the simplest H-block joint after months of effort. Their conclusion: either we're missing a fundamental technique or the builders possessed knowledge we've yet to rediscover. Every flawless edge, every mirror-smooth surface whispers the same humbling truth. Some chapters of human ingenuity remain stubbornly closed to us, their secrets locked in stone. Deep in the mineral collections of the Eastern California Museum sits a small, unassuming artifact that shouldn't exist, a rusted metal cylinder embedded inside a hardened geode, unearthed in 1961 by rock hounds searching for gemstones near the Coso Mountains. At first glance, it resembles a vintage spark plug from an early 20th century engine. But here's where the story twists. The encasing rock was dated at 500,000 years old. This is the Coso artifact, a relic that catapults us into a collision between geological timelines and human invention, one that refuses to be neatly explained away. Initial dismissals pointed to a modern object somehow lodged inside ancient stone. Skeptics proposed that mineral-rich water deposited layers around a discarded spark plug, creating the illusion of extreme age. But when geologists examined the concretion, they found a problem with that theory. The geode's internal structure showed no signs of recent disturbance. Its crystalline bands had grown uniformly around the metal core over millennia. X-rays revealed more anomalies. The artifact's interior housed a porcelain-like insulator and a copper spring components matching early 20th century technology, yet trapped in stone that predates Homo sapiens. Then there's the metal itself. Spectroscopy revealed an alloy of iron, nickel, and zinc, with trace elements unlike any known spark plug from the 1920s. The proportions eerily resemble meteoric iron, yet the object's symmetrical design and threaded end scream human craftsmanship. Even stranger, the outer layer had oxidized into a rare form of iron oxide called goethite, a transformation that typically requires tens of thousands of years under specific conditions. Modern replicas subjected to accelerated aging tests fail to replicate this chemical fingerprint. Could this be proof of a lost industrial civilization, as some fringe theorists claim? Probably not, but it might hint at something equally fascinating: natural processes mimicking advanced technology. Certain mineral formations, like pyrite nodules, can self-assemble into geometric shapes resembling machined parts. Other theorists propose the artifact is the remnant of an ancient, naturally occurring battery, similar to the Baghdad find encased by geological chance. Yet the most compelling twist lies in the human angle. Before spark plugs, before metallurgy, what if early humans stumbled upon naturally occurring metallic curiosities and replicated them? Aboriginal cultures worldwide used meteoric iron for tools millennia before smelting. The Coso object's design, while startlingly modern, might reflect an intuitive grasp of materials we've since forgotten. What lingers isn't just a question of origins, but of perception. The Coso artifact forces us to confront how easily we project our own technological framework onto the past, and how rarely we consider that nature might have beaten us to the punch. Whether an echo of lost knowledge or a geological prank, it remains a fossilized riddle, daring us to rethink where invention truly begins. Deep in the vaults of Bogotá's Museum of Gold, a collection of tiny artifacts sits behind glass, delicate golden figurines no larger than your thumb, crafted by Colombia's Quimbaya civilization over 1,000 years ago. At first glance, they look like stylized birds or insects with swept-back wings and tapered bodies. But tilt your head slightly and something startling emerges. These shapes bear an uncanny resemblance to modern aircraft. Delta wings, vertical stabilizers, even what appear to be cockpit canopies, every curve and angle mirrors the aerodynamics of jets and fighter planes. How could a pre-Columbian culture, millennia before the Wright brothers, create objects that seem to defy their own technological timeline? The controversy centers on 6 particular figurines, often dubbed the Quimbaya airplanes. Unlike traditional zoomorphic art from the region, these pieces lack features like feathers, eyes, or legs. Instead, they showcase sleek, streamlined forms with precisely angled wing surfaces that align with principles of lift and drag. When engineers modeled these shapes in wind tunnels, they discovered something extraordinary. The figurines generate stable flight dynamics. Some even produce minimal turbulence at speeds matching small propeller planes. Of course, skeptics argue this is coincidence. Perhaps the Quimbaya simply crafted abstract birds, and our modern eyes impose familiar shapes onto ancient art. After all, pareidolia, the tendency to see faces in clouds or animals in rock formations, is a well-documented human trait, but here's where the mystery deepens. One figurine, known as Object 5, features a rear stabilizer positioned below the fuselage, an arrangement never seen in nature, yet identical to the tail design of modern fighter jets. Another shows a distinct bifurcation at the wingtips, resembling the winglets on commercial airliners that reduce drag. These aren't vague similarities, they're specific engineering choices that serve no decorative or symbolic purpose if the artists were merely depicting wildlife. Proponents of the ancient aircraft theory point to broader cultural clues. The Quimbaya were master metallurgists, producing gold alloys with melting points perfect for lost wax casting, a technique requiring precise temperature control. Could they have observed natural phenomena like gliding seeds or wind-borne insects and extrapolated aerodynamic principles? Some researchers suggest these figurines might represent ceremonial models of mythical flying machines passed down through oral traditions. There's even a fringe hypothesis linking them to pre-Columbian balloon experiments, citing indigenous legends of sky chariots woven from reeds and animal hides. Yet mainstream archaeology offers a simpler explanation. The figurines likely depict stylized stingrays or flying fish. The Quimbaya lived near rivers teeming with these creatures, and many other artifacts from the era clearly portray aquatic life. The cockpit could be a fish's blunt head, the wings flattened pectoral fins. Computer modeling by biologists supports this. When the shapes are rotated to simulate swimming rather than flying, their hydrodynamics are equally impressive. The debate crystallizes a fundamental challenge in studying ancient art, separating artistic abstraction from potential technological insight. The Quimbaya had no written language, leaving no manuals or blueprints to explain their intent. What survives is the craftsmanship itself, a testament to observation, whether of nature or something more extraordinary. Modern reconstructions add another layer. In 2013, a team built scaled-up radio-controlled models based on the figurines' proportions. To everyone's surprise, they flew not just clumsily, but with stability rivaling hobbyist aircraft. This doesn't prove the Quimbaya understood aerodynamics, but it does raise haunting questions about how closely their designs align with functional flight. Perhaps the truth lies somewhere between the poles of skepticism and speculation. These golden artifacts might not be proof of ancient aviation, but they're undeniably more than simple trinkets. Every polished curve, every calculated angle whispers of a culture that observed the world with razor-sharp precision, whether studying the glide of a fish or imagining the possibilities of the sky. In the end, the Quimbaya airplanes remain open to interpretation, a riddle cast in gold, waiting for us to decipher whether we're seeing art, accident, or something far more profound. Discovered in a remote mountain cave along the China-Tibet border in 1938, the Dropa stones have fueled debate for decades, not for what they are, but for what some claim they might represent. These fist-sized stone discs, each grooved with a delicate double spiral pattern radiating from a central hole, would be unremarkable if not for the wild theories surrounding them. According to a controversial account by archaeologist Kai Pute, the cave also contained skeletal remains of small, large-headed beings alongside walls painted with celestial imagery. This discovery birthed the legend that the Dropa stones were records left by an ancient alien civilization, their spiral grooves encoding messages from the stars. But let's separate myth from material reality. The stones themselves are undeniably ancient, carbon dated to around 12,000 years old. Their grooves, though precise, resemble those found on Neolithic thread walls, tools used for spinning cordage. Similar artifacts appear across Eurasia, often interpreted as ritual objects or spindle weights. Under a microscope, the grooves show where patterns consistent with fibers being pulled through them repeatedly, suggesting a practical function in textile production. Yet the Dropa stone spirals are unusually intricate, with some featuring secondary channels that branch like circuitry, a detail absent in most walls. The alien narrative gained traction in the 1960s when Russian researcher Dr. Vyacheslav Sazev allegedly translated glyphs along the spirals, revealing an account of spacecraft crashing in the Himalayas. But here's the catch: no credible linguist has verified these translations, and the original stones with inscriptions have never been exhibited. Mainstream archaeologists argue the glyphs are likely natural striations or later carvings added to inflate the artifact's mystique. What's often overlooked is the cultural context. The cave lies in the traditional lands of the Dropa or Dizopa people, whose oral histories speak of small, thin beings who came from the clouds. Anthropologists suggest these tales more likely describe encounters with another migratory tribe, distorted over millennia. The stone's spiral motifs mirror symbols found in Tibetan Buddhist mandalas, representing cosmic harmony, not extraterrestrial blueprints. Modern analysis adds another layer. X-rays reveal the stones contain high concentrations of cobalt and other metals, unusual for ordinary walls. Some speculate they could have functioned as primitive batteries or piezoelectric devices when struck, akin to the Baghdad Battery theory. Yet without corroborating artifacts or written records, these remain speculations. The Dropa stone's real mystery isn't alien contact, it's why a simple tool became a canvas for our cosmic fantasies. Perhaps their true lesson lies in how easily we project our modern obsessions onto the past, turning Neolithic spinners into starship logs. The grooves remain silent, but their echoes shape stories far beyond their makers' intentions, proof that some technologies don't just create objects but legends. Deep within the temple of Seti I at Abydos, a series of hieroglyphs carved into a ceiling beam have ignited one of Egyptology's most persistent controversies. At first glance, the symbols appear to depict uncanny resemblances to modern helicopters, submarines, and even futuristic aircraft, silhouettes so precise they seem lifted from a 20th century engineering manual. These Abydos helicopter glyphs have become ground zero for debates that straddle the line between archaeological oversight and wild speculation. How could art from 3,000 years ago mirror technology millennia beyond its time? The answer lies not in ancient astronauts or time travel, but in the fascinating phenomenon of palimpsest carving, a mundane yet extraordinary process where history rewrites itself in stone. The key to unraveling this mystery is understanding how Egyptian monuments evolved over generations. Pharaohs often reused sacred spaces, erasing or modifying earlier inscriptions to suit new ideologies. In Seti I's temple, his son Ramses Roman II later superimposed his own cartouches and imagery over existing carvings. Over time, erosion and deliberate recarving blended layers, creating accidental composite images. The helicopter emerges where Ramses' plaster infill crumbled away, revealing fragments of Seti's original hieroglyphs beneath a collision of bird symbols, snake glyphs, and solar discs that, when viewed from our modern perspective, coalesce into shockingly familiar shapes. It's essentially a Stone Age version of a double-exposure photograph, where two moments in time overlap to form something neither artist intended. Modern Egyptologists have meticulously deconstructed these glyphs. The rotor blades of the so-called helicopter are actually parts of a bee hieroglyph representing royalty from Seti's era, while the cockpit derives from Ramses' overwritten arm and scepter motif. Similarly, the submarine profile combines a chiseled-over lotus flower with remnants of a water ripple symbol. What we perceive as futuristic technology is simply the archaeological equivalent of visual static, a chance alignment of cultural noise. Yet the allure of fringe theories persists. Proponents of the ancient tech interpretation argue that the glyph's precision defies coincidence, pointing to similar anomalies in other cultures' art. Some suggest the carvings document encounters with advanced machinery, perhaps from a lost civilization or even extraterrestrial visitors. Others propose more esoteric explanations, that the glyphs encode prophetic visions or interdimensional knowledge. While these ideas capture imagination, they overlook a critical detail. No other Egyptian site shows comparable imagery, and the Abydos vehicles vanish when examined as individual hieroglyphic components rather than holistic shapes. What makes the Abydos glyphs so compelling isn't just their appearance, it's how they hold up a mirror to our own biases. Humans are pattern-seeking creatures, wired to find familiarity in randomness. We see faces in clouds and religious figures in toast. The helicopter glyphs are essentially a Rorschach test for the technological age. The irony is rich. A culture that documented everything from tax records to funerary rituals left no mention of aircraft or submarines, yet we project our own technological framework onto their symbolism. The deeper lesson here transcends Egyptology. The Abydos helicopter reminds us that history is often a palimpsest itself, layer upon layer of interpretation, where the truth can be obscured by both time and our own expectations. Every chip in the stone, every faded pigment fleck whispers the same cautionary tale. Sometimes the most mysterious artifacts aren't proof of lost science, but evidence of how eagerly we mistake the echoes of the past for messages meant for us. The real enigma isn't carved in the temple ceiling, it's woven into the way we choose to see. While the Nazca lines captivate with their intricate animal figures, Bolivia's Sajama lines hold a different kind of awe, not through complexity but sheer overwhelming scale. Spread across the high-altitude plains near the Nevado Sajama volcano, this sprawling network comprises over 16,000 perfectly straight pathways etched into the earth, stretching more than 10 miles each in some cases. If laid end to end, they'd wrap halfway around the planet. Yet their precision is what stuns researchers. These lines carve across rugged terrain, over hills and through valleys, with deviations of less than a single degree over vast distances. How did an ancient culture, working without theodolites or aerial surveys, achieve such geometric perfection? The answer might lie in a blend of celestial intuition and forgotten engineering techniques. Unlike the Nazca lines designed to be seen from above, the Sajama lines serve a practical purpose visible at ground level. Indigenous Aymara communities have long used them as pilgrimage routes connecting sacred sites and water sources. But their construction defies simple explanation. The lines aren't mere footpaths, they're meticulously cleared corridors, sometimes just a foot wide, bordered by low stone markers. Infrared imaging reveals that the underlying soil was often heated before being scraped away, a process that hardened the surface and prevented erosion. This wasn't haphazard trailblazing, it was a systematic, large-scale land survey executed with mathematical intent. The real mystery isn't just the straightness but the altitude. At over 13,000 feet above sea level, The thin air and harsh winds make even basic labor exhausting. Yet the lines maintain their precision across mountain slopes where modern engineers would rely on GPS. One theory suggests the builders used celestial alignment, staking lines by Polaris or the Southern Cross, while others propose they harnessed natural landforms as visual guides, creating sightlines between distant peaks. Experiments with replica tools show that simple wooden stakes and ropes could achieve near-perfect alignment if teams worked in coordinated chains, adjusting angles incrementally over miles. Yet even this method struggles to explain how the lines remain flawless where the terrain dips and rises sharply. What's often overlooked is the cultural context. For the Aymara, straight lines aren't just practical, they're sacred. Their cosmology views rivers and mountain ridges as earthly mirrors of celestial pathways. The Sajama lines might have served as a terrestrial map of the heavens, a way to physically walk the roads of their gods. This spiritual dimension adds another layer to their precision. If the lines were meant to channel divine energy or mirror cosmic order, even minor deviations could disrupt their ritual function. Modern Aymara elders still speak of the lines as threads connecting the living world to the spirit realm, woven with a care we've yet to fully comprehend. The contrast with the Nazca lines is revealing. While Nazca's glyphs were likely ceremonial, meant to be seen by deities above, the Sajama lines were participatory, meant to be walked. Their endurance is a testament to their purpose. Where Nazca's fragile topsoil designs could vanish in a storm, Sajama's engineered pathways endure centuries later. Both achievements whisper the same truth: ancient cultures didn't just shape the land, they conversed with it, turning geography into a canvas for both utility and transcendence. Every straight path etched into the Bolivian Altiplano is a silent challenge, asking us to reconsider what's possible when human ingenuity aligns with the rhythms of the earth and sky. From the celestial tracking Antikythera Mechanism to the rust-resistant iron pillar of Delhi, these 30 ancient technologies reveal a haunting truth: human ingenuity has flickered in brilliance across millennia, often burning brightest in civilizations we've wrongly labeled primitive. Each artifact we've explored, whether Damascus steel blades laced with carbon nanotubes, Roman concrete that heals itself, or the aerodynamic gold figurines of the Quimbaya, chips away at the arrogant assumption that progress is a straight line. The past isn't a crude draft of the present. It's a mosaic of lost mastery where insights emerged, vanished, and sometimes reincarnated centuries later under different hands. Consider the eerie parallels. The precision of Puma Punku's stone joints mirrors modern laser cutting, while the Baghdad Battery's electrochemistry predates Volta by 2,000 years. The Nazca and Sajama lines demonstrate how cultures separated by continents and centuries shared a compulsive drive to etch meaning into the earth itself. And who could forget the hanging pillar of Lepakshi, defying gravity with nothing but counterbalanced stone, or the Greek fire that turned water itself into fuel? These weren't flukes, they were peaks of knowledge that collapsed into silence, waiting for us to stumble upon their fragments and wonder. What unites these marvels isn't just their sophistication, it's the humility they impose. We've rewritten history repeatedly, each discovery proving that ancient minds grasped concepts we thought were born in modern labs. The Dropa stones and Koso artifact remind us how easily we dismiss anomalies that don't fit our timelines, while the Dendera light and Nimrod lens hint at optics advanced enough to make us question which dark ages were truly dark. Even the Voynich Manuscript, undeciphered after centuries of scrutiny, stands as a monument to the limits of our understanding. This isn't about ancient aliens or lost supercivilizations. It's about recognizing that brilliance is a flame passed between cultures, often extinguished by war, time, or sheer forgetfulness. The real mystery isn't how these technologies worked, but why their secrets were buried so completely. Perhaps the answer lies in the fragility of knowledge itself: a single burned library, a discontinued apprenticeship, or a guarded trade secret taken to the grave can erase centuries of innovation. So let these wonders ignite your curiosity. Question the textbooks, marvel at how much we've forgotten, and how much still waits beneath deserts and jungles hidden in plain sight. The past isn't done speaking, it's just waiting for us to ask better questions. Now it's your turn. Which of these ancient marvels leaves you awestruck? Drop your thoughts below and let's keep the conversation alive. After all, the next great discovery might start with a single spark of curiosity.